Hi students, let us draw some ray diagrams for image formation in convex lens for different positions of object. Suppose if we keep object in front of a convex lens, so in this diagram, so this is the various positions of the object. Suppose if we keep at different positions of the object in front of this convex lens, and we need to guess where is the position of the image. So if object is at here, means we can say it is at infinity. So we can predict where is the image is at focus. So like that, we will change different positions in front of the convex lens, and we will notice where will be the image. So in this all the cases, the image in this case, if object is just beyond 2f, the image is between f and 2f. So here we need to see what is this type of the image. So we will draw certain ray diagrams. With the help of the ray diagrams, we will understand for the various positions of the object and how the image will be formed. So we need to learn this table along with the ray diagrams carefully. So this table is very important question regarding the examination point of view. So that tells about nature, position and size of image formed by convex lens. So let us see that, suppose if I take a real setup, I am having a real setup at here. So in this setup, this candle is my object. Now I can place this candle along this principal axis. So for a moment, if we can take to explain, so this f is a focus or focal length. This is a 2 times f, means the focal length gets doubles. So the line, imaginary line, is the principal axis. So I will keep this object, so here my object is a candle, at different positions. Now this is my first position. So if we can write that if object is at infinity, now position of object at infinity. Where is image? Image is at focus. Now what is the nature of image? The image is point size, and the image is real and inverted. So how do I know that it is a real image and inverted image? If you can see, the convex lens always forms an inverted image, and for next two positions we can understand clearly. And where is the position? Position is at focus, so this is the focus of the convex lens on the other side. And what is the size of the object? It's a point size, very small point. And the image type is, image is real and inverted. And one more point I need to talk here, yeah, nature, type. Now if the object is at infinity, so this is the location of the image, the location of image is at focus, and nature of image is point size and real and inverted. Now for the second location, I can change the location of the object and try to observe the position of the image. Now if I keep object just beyond 2f, so this is the position which I am selecting. If the object is just beyond 2f, since the object is close to 2f, some of the light rays are not passing through the lens, so you forget about that. Anyway, we need to concentrate about two lines to draw the ray diagrams. So out of these three lines, you can select any two lines to draw the ray diagrams. The first ray, if we can take an object which is parallel, so this is the line which is parallel to the principal axis. After refraction, it is passing through the focus, so that is the line you can take in. And the second line, if you can take a line which is passing through the optical center, so this line do not deviate. So by taking that two, we will draw a diagram. So the rest of the lines which are not passing through the lens, so you just leave it. Now, if object is position of the object just beyond 2f, object is beyond 2f. Now where is the image? Yeah, the location of image is between f and 2f. Image is between f and 2f. Now what is the nature of the image? Now here you can see the image is small in size, if you can compare the object size and image size, the image is smaller than the object. And now the image is real image. Why? Because it is forming other side of the object, so we can call it as real image. And the image is inverted. So if object is beyond 2f, the image forms between f and 2f, and the nature of image is small in size and it is real and inverted. So this is the second case. Now let's take the another case. Now we will bring object close to the convex lens. Now in that case, if I place object at 2f, now object is at 2f, object at 2f, the position of object at 2f. Where is the position of image? Image is also forms at 2f. But at 2f, that is the other side. Yeah, that's common sense to understand. And now here you can see the image size same that of object, same size of object. It means, so that is the position where we get image same size of the object. Now we can write the nature. So the nature of image is real and inverted. So if object is at 2f, image also forms at 2f, but on the other side. So if we can mention that, to not give confusion, I can write that the image also at 2f, but the image is at other side. And the size of the image, same size of the object, and the image is real and inverted. Now let's change the position of object. Now if we take object is between f and 2f. Now if we can place object between f and 2f. Now I can write it here, object between f and 2f. Now where is the image? So image is beyond 2f. Image is beyond 2f. Now we can write the nature of the image. First, the size is enlarged, so it means bigger than the object. The size is enlarged, and the nature of the image is it is a real image and inverted. So if object is between f and 2f, image forms beyond the 2f, and the image is enlarged image, means bigger in size, and nature of image is real and inverted. Now let's change the case. Let's bring object some more closer to the lens. So if you can take that as a case, if I keep object at focus, now my object is at focus, object at f, and where is image? So here we cannot find image at here anywhere, but we can understand these light rays are parallel light rays. So it means if these are the parallel light rays which is passing through the lens, so they do not meet at all. So in this case we cannot find image on the screen, so the image is at infinity. Because all these light rays which are the passing through the lens, they are the parallel. If once these light rays are the parallel, so they do not going to converge at all. So they will expecting to meet at infinity. So this is a hypothetical situation we can talk. So we can say if object is at focus, the image forms at infinity, and we can write the nature of the image. So it is highly enlarged, and the image is real and inverted. The nature of image is real and inverted. So this is the special case which we get image at infinity. Now let's discuss one more case. Let's bring object close to the lens. It means if I keep object between f and optical center, so if you can see it here, object position. Now object is between f and O. Here I can call this O. O stands for optical center. If object between focus and optical center, and where is image? Now image forms on the same side of the object. Now here we can say image is virtual and erect, and image is enlarged. So this is a very special case for the convex lens. In this case only we will use convex lens in the microscope to see the very small objects. So if we can keep object between focus and optical center of the convex lens, image is also forms on the same side of the object. If the image forms on the same side, so we can call that image as a virtual image. So we can call that image as a virtual image. So how we can say it's a virtual image? If the image is forms on the same side of the object, we call that image as virtual image. And here we can see the size of image is enlarged, bigger than the object size, and the image is erect. Erect means straight. So these are the different positions of an object, how a convex lens forms image. So likely we will see for the concave lens also. Concave lens is not having so many cases like this convex lens. Concave lens having only two cases. Let's see for the concave lens how a concave lens forms image for the different positions of the object. Now at here, if I switch the lens to concave lens, if it is a concave lens, here we can see the conditions. We are having only the two cases. If the object is at infinity, another case if the object is between anywhere between f and the 2f. So these are the two cases we need to discuss if it is a concave lens, and we can see what are the corresponding image characteristics. So the image characteristics which is shown at here. So if object is at infinity, where the position of image forms at focus, and nature of the image is diminished and point size, and the image is virtual and erect. Or other than that, if you can place between infinity to optical center of the lens, anywhere if you can place, the image also forms between optical center to O, and image always forms virtual and erect image. So let's see these two cases with the help of the virtual stimulation. So if you can keep object at here far away, so that is my first position, object at infinity for a concave lens. So this is set up for the concave lens. So if the object is at infinity, where is the position of the image? Now here you can see the image position is at f. Image is at f, and image is also forms on the same side. So if the image is forms on the same side, we can say that image is virtual image. And if you can compare the size of the object to size of the image, object size appears bigger and image size appears smaller. So we can say image is diminished. Image is diminished. And the nature of image is it's a virtual and a erect image, upright. So if object is at infinity for a concave lens, image forms at focus and the image is smaller in size, very diminished image, and the image is virtual image. Now other than the infinity, if you place object anywhere between infinity to optical center, so that is our second case. Now second case, object between infinity to O. O means optical center. If object is between infinity to optical center, it means if I can move object from infinity to optical center. So if I can place it here just beyond the 2f. Now where is the image? Image is forms between f and I. So if you can locate anywhere between. Now if you can see, the image is always forms between the focus and optical center. Now in this case you can see, if you can bring close to the lens, the image always forms between focus and optical center. So if I can write in this case, if object between infinity to optical center, so image is between F and O. So it always forms between F and O, focus and the optical center. And what is the nature of image, you can write? So the nature of image is smaller in size, or you can use the word diminished, and this is the size of the image. Now if you can write the nature of image is virtual and erect. So concave lens always forms virtual image. So that's why the image is always formed on the same side of the object. But if you take convex lens, there is one particular case for the convex lens which can forms virtual image. So these are the two lenses corresponding ray diagrams. So follow NCERT textbook carefully and draw the ray diagrams carefully. Not only that, try to learn these two tables which is given at here. So table 10.5 and table 10.4. So what is the nature, position, size of an object which forms different positions of the image? One for the convex lens and one for the concave lens. So this table is very important, table 10.4, the image formation for the convex lens and image formation for the concave lens.